Okay, my phone says that it's a quarter past 2, so let's get started. My name is Hans de Goede, and I'll be talking to you this afternoon about support for Allwinner ARM SoCs. So first I want to quickly introduce which SoC Allwinner's made. Then I want to talk about U-Boot, what was supported, what currently is supported about a year later, the kernel, and then the roadmaps of the two. So Allwinner's SoCs, which SoCs does Allwinner make? Allwinner started with a number of SoCs which are not on this slide, which were used in MP3 players and MP4 players, so small video players. And they're not really interesting because you cannot really properly run Linux on them. And they're not ARM v7, they're older than ARM v7, and I only care about ARM v7 to be honest. So Allwinner's claim to fame was the A10. The A10 was one of the first Chinese SoCs to be really integrated. Allwinner actually, when they introduced the A10, they caused a large number of companies in the Schengen district in China to go bankrupt. Because before the A10 there were a lot of different components on a motherboard of a tablet. And the A10 integrated almost everything inside the SoC, so the motherboard of the tablet is pretty much empty beside the SoC. Which meant that a lot of companies who were delivering some of the more small components which were integrated went bankrupt. That was their claim to fame, and it really helped to get tablet prices down to a whole new pricing level. The A10 was their first SoC. It was a single core. It had Mali 400 graphics, something which they've stayed with for a large number of other SoCs. One of the other cool things which the A10 has, which unfortunately only the A20 also has, no other SoC from Allwinner has that, is it has an integrated AHCI controller, so it has native SATA. So you can actually attach a disk or an SSD via a SATA connection instead of via USB. And that means that you actually get decent performance out of it, because USB mass storage is a suboptimal protocol, let's put it that way. USB mass storage sucks when it comes to speed. As I said, it had lots of stuff integrated, including they not only targeted tablets but also top set boxes, which was where the SATA came in, and also they had 100 megabit Ethernet integrated and HDMI output. After that, for each SoC which they introduced a budget version where they cut off some pieces. So later they did the A13, which is basically the same chip but they removed the SATA. And it has less pins, so it has less memory bandwidth. Then they went to a dual-core version, and again, cheaper. Then they did a quad-core version, and with the quad-core version they did a number of things which sucked. The first thing which sucks about the A31, which is the first quad-core version, is they used PowerVR graphics. And with Mali graphics there are some efforts to reverse engineer them, and hopefully one day we'll actually get an open source driver. With PowerVR graphics, it's not very likely we'll ever see an open source driver. Another thing which they did was they removed SATA. It was their flagship product, but it didn't have SATA. And another thing which they messed up is the A31 does not boot from SD card by default. All the other Allwinner SoCs have this nice feature that if you put in an SD card in the first SD card slot, and almost all the devices have an SD card slot, it will automatically boot from that SD card if there's the proper magic signature on there. So you cannot brick the device, you don't need to root it, you just put in an SD card with a magic signature and it will boot from your SD card. It's brilliant, except the A31. The A33 is the budget version. They fixed a number of things there. They went back to Mali. It boots from SD card again. And their latest flagship product is the A80, which is an octa-core. It's a big little architecture. Again, they did PowerVR graphics. I think it does boot from SD cards by default, I'm not sure. And their latest budget product is the A83, which is 8 A7 cores, which is a bit crazy if you ask me. And again, it has PowerVR graphics. The A83 we'll soon know more about. It's still sort of very new, so we don't know that much about it. So U-Boot. I initially gave this presentation at FASTEM, so I don't hope there's anyone in the room who saw the same presentation at FASTEM. So I started at FASTEM with comparing it to FASTEM a year before. So FASTEM 2014, there was no upstream U-Boot support for Allwinner SoCs at all. There was some support in the fork, but not in the main upstream repositories. It did support the A10 and A20, which are very much alike. It did not support any of the other SoCs. It did not support video output, so if you were to boot U-boot on a tablet and it would stop at U-boot because you had an error in your U-boot config or whatever, it wouldn't show you anything. It didn't support booting from USB, it didn't support booting from SATA, it was pretty poor. In a year we did a lot of work. We got the basic support upstream. We added support for the A23 and A31. In my personal branch, and I'll probably send a pull request for that tomorrow, because I just got the latest X, is A33 support. A80 support is work in progress. And we got something which is called PSCI working, currently only on the A20 SoC. Does anyone here know why we would want to have PSCI working? PSCI actually is sort of PC-like. It's like with ACPI. You keep your firmware active and you can call back into the firmware. And that's necessary on ARM to be able to start up your CPU cores in hypervisor mode. So on the A20 we can actually start the CPU cores in hypervisor mode. And that means that you can actually run KVM on them. So you can run hardware accelerated virtual machines on a $30 small board computer. So if you want to run VMs, you no longer need a PC of €300-400. You can do it on a $30 small board computer, like the Raspberry Pi. And you can run hardware accelerated virtual machines on there. So that one's also cool. We got video output working. We started with HDMI, and then once we had that, it was really quick to also add support for LCD screens and VGA output on boards which have it, etc. I already said that the A10 is sort of a crazy design. They integrated everything. It even has VGA digital analog converters in there, so it just has a number of VGA pins. You can just hook up a VGA connector if you want, and you have VGA output on your tablet or on your small board computer. We got USB working, both host mode and on-the-go mode, and we can boot from SATA. Booting from SATA is a bit unfortunate because U-boot can boot from SATA, but the SoC itself cannot, so you still need like a 512 megabyte SD card just to put U-boot on there. And then everything else can be on SATA. So how do things look from the kernel side? We actually already had some stuff upstream in FOSDEM 2014. You could boot the board and you could get a serial console. And you could put a root file system on NFS because we had 100 megabit Ethernet working. Since then we have gained support for pretty much every other SoC from Allwinner. 1 gigabit Ethernet, USB host mode, SATA, infrared, tablet keys, so your volume buttons and your home hardware button, etc. on tablets, resistive touchscreens, MMC or SD card, so we can now actually put a root file system somewhere, because before that we only had a RAM disk or NFS. Simple FB. Simple FB is a mechanism where we take over the frame buffer as it's been set up by U-boot. So previous slide I said that in U-boot we now have pretty much all the video outputs working and the kernel can just take it over. We don't have mode setting yet, you cannot change the mode, but at least you get a display, which is pretty nice to have a display. So what are the plans for U-boot? First let me tell you something about new SoC support. If you look at most SoCs, they do not know how to talk to DRAM, to talk to your external RAM. Right, your external RAM is all dynamic RAM, and programming dynamic RAM needs a lot of timing parameters and stuff like that. Usually the SoC cannot do that out of the box. So what it does, it has a really small internal boot ROM, which will first look for the magic signature on the SD card. And then after the magic signature, it will read 32 kilobytes of code. No more, you get 32 kilobytes of code. It's like you're working with a microcontroller. Those 32 kilobytes of code get copied to an internal SRAM, because the SoC doesn't have DRAM working yet. And then in that 32K of code, you get to set up DRAM. But you cannot set up DRAM, you need to begin with setting up all the clocks, all the POLs, so that you actually have a clock to clock your DRAM. And then you need to set up your I2C controller, so you can talk to your power management IC, which is a separate IC which makes a lot of separate voltages. It has a lot of DC-DC converters and LDOs. And then when you can talk to your power management IC, you can actually power your DRAM. And then when you have your DRAM powered and you have your DRAM clocked, then you can start to worry about actually activating the DRAM. And then you have the DRAM fully programmed and activated and it works. And you all of a sudden have access to like half a gig of RAM instead of 32K codes. You need to load the real U-boot binary, which usually is, U-boot is small, it's like 200, 300K of code, but it's too big to fit in the initial phase. To load the real U-boot binary, you also need SD card support. So the first step we call the SPL. It's called for secondary payload, because the primary payload is the ROM inside the SoC. That's where the CPU starts executing, and the SPL is the secondary payload, and U-boot itself is the TPL, the tertiary payload. Some SoCs even have a quaternary payload, because there the first SPL isn't powerful enough to do everything, and it loads like another helper, and then that loads the real U-boot. But we only have the SPL and the real U-boot. So the first thing what we actually do is all the initial setup. That's the hardest part. Getting the clocks running, getting the power up, initializing the DRAM. That's all pretty dark magic, and it's all non-documented. So usually we start with using an Allwinner binary for that. So we just use what Allwinner calls boot 0. Boot 0 is what U-boot calls the SPL, the secondary payload. We start by using that, and we just write our own U-boot, so that at least we have open source running and we can poke registers and see how the DRAM controller has been set up, etc. Once we have that going, we actually start writing the SPL. And once we have the SPL going and the main U-boot, then we do all the nice to have stuff like Ethernet support, so you can boot from the network directly from U-boot, USB support, video output support, etc. So about the roadmap, I'll get back to that later when I talk about the A80. A33 support currently is finished, pretty much. As I said before, I just got the latest X to a few patches, so I can send a pull request now and then it's done. And it's complete. The A33 support includes video support, USB support, everything. The A80 is a different story, because the A33 is sort of an evolutionary step from the A23. The A80 is a completely new design. Step 1 is complete. In my personal repo, there you can build a U-boot binary, and you can use the boot 0 binary from Allwinner, the blob, to load U-boot, and we have that running. But the next step is very hard, because they have two CPU clusters, the A15 cluster and the A7 cluster, and they both have their own power management IC. So instead of one PMIC, we have two PMICs. I already have code to talk to both of them. I can read their identification register, and so that's working. But I have no idea which power plane is hooked up to what. Which is tricky. And the DRAM controller looks significantly different, so Allwinner actually recently released some code for both these things. So we should be getting somewhere. But to be honest, another problem is I'm not really that interested in the A80. The interesting thing is that with Allwinner I can buy a tablet like this one for $35. A80 designs start at $120 for a set-top box, so you don't get a screen or anything. A83 support, as I said before, Allwinner is doing a cheaper version of the A80 like they did with all their previous A series. The A83, Allwinner has published documentation and source for us. So we have datasheets, we have source code for the bootloader, we have source code for their own Android kernel, which is based on Linux 3.4, or ancient. And they are shipping some hardware samples to key community members in the Allwinner open source community, the upstream community. So, from the kernel side of things, what are we working on? In 4.0 we merged a lot of stuff. We merged CPU frequency, so we can actually not run the CPU at 1 GHz, which is nice if you have a battery that you're not constantly running it at 1 GHz. As I said before, the A10 Allwinner integrated everything. They integrated everything and the kitchen sink. The thing has a CAN bus controller inside, because they could put it in there. And maybe someone ever would want a CAN bus controller in a SoC. The thing also has actually a hardware PS2 controller, so an i8042 controller in there. So well, someone actually wrote a driver for that, that's merged now. So you can hook up a PS2 keyboard to your small board computer, if you want to. And it's supported. A number of minor other things. This one is important. We got MMC support for the A80 merge, so you can now actually pretty much boot an upstream distro on your A80 as long as you use the boot 0 binary from Allwinner. And we got the power management IC driver for the AXP221 merged, which is used in the A23 and A33. This says planned for 4.2, and over here we have 4.0. This is a not so funny story, at least I don't find it funny. We had a lot of stuff queued up for 4.1, but the ARM subsystem maintainer missed the merge window. So now we have a lot of stuff queued up for 4.2. Specifically, we have, for the A23, we have SMP support. Currently, we can only use one of the two cores in the kernel. This will bring up the second core. For the A31, we have power management support. So for support for the external PMIC, so we can actually do change the CPU voltage, which in combination with CPU frequency gives us a lot of power saving. And for the A80, we have support for the USB controllers, the USB hosts. Real soon now, we hope to merge USB on the go support. It's actually already working. I'm using that to use this keyboard with a tablet because most tablets only have an OTG port. The SoC has real USB host ports, but usually they're not routed to the outside. And audio, analog audio out, which is usually useful for top set boxes. And work in progress, NAND support. NAND support sort of is in the freezer. Someone did an initial patch set and no one is really working on it. Someone needs to pick that up. And hardware crypto engine support is actively being worked on. Because the A20 and later have a hardware crypto engine which can do a number of crypto things like DES in hardware. And we're adding support for that. A demo. Okay. So I had a subtitle for this talk. Don't know if anyone saw it. A $40 US tablet. So let me see if I can keep that promise. This is the first one which I have to demo today. This one is $36 including shipping to Europe. And that is this one. It's a dual core, it's the A23. It comes with half a gig of RAM. And it should, demonstration effect, boot Linux. This is U-boot. In U-boot you can actually hook up a keyboard because the on-the-go controller works in U-boot. Now we're in the kernel. We cannot hook up a keyboard there yet. Don't have OTG support working yet. So this will boot all the way to a graphical login screen, and then we cannot do anything because I don't have touchscreen support yet. I don't have USB support yet. So, but the basic works. The display works. The next tablet, also still under the promised $40, is this one. This one is actually really interesting. I really like this one for a number of reasons. One of the reasons is this one was intended as an e-reader, I think, and it has a pretty good screen. It has an IPS screen actually, and a weird orientation because it was intended as an e-reader. But this one actually has everything working pretty much except for the GPU. Even the internal storage, because they didn't use NAND, they didn't use roll NAND. It has an eMMC, an embedded MMC inside, which needed a little prodding, but that works now too. USB, Wi-Fi works, USB on the go works, both in host and application mode. So I can also hook it up to my laptop and then it will show up as a serial console over USB. Everything just works except for the GPU. So if you want a tablet to play with regular Linux on, you can just buy this one, the Uto P66, and it's $36. You get a IPS screen, half a gig of RAM, single CPU core. The other one was a dual core, but so yeah, you lose a core, but you gain IPS, and you gain a working touchscreen, which is supported in the upstream kernel and things like that. So I have one more, which doesn't completely fulfill my promise of being less than $40 or less. It's a shocking $47, which is this one. This is just the big brother of this one. This one is completed booting now. So this is a dual core, half gig of RAM, 2 cores. And this is the quad core version, and you get a slightly higher resolution screen. And yeah, it's about $10 more expensive. So if you want to play with these later, you can come to the front after the end. Are there any questions? You guys need to fill 10 minutes with questions, otherwise I'm not sticking to the time schedule. So. No questions at all?
The NAND support
I don't completely understand the question. Can you?
There was a work in progress for Node support.
It's for actually talking to the NAND. The NAND is usually used in combination with a flash controller, like in a USB stick or in an SSD. But you can also have roll NAND access. These SoCs have their own NAND controller built into the SoC, and they use roll NAND chips. So you need to do a lot of things like ECC and randomizing and all those kind of stuff which you need to properly deal with NAND in the software, basically, in combination with some hardware which helps you to do that. There's a NAND controller in there. So you just needed to be able to access the NAND at all. That way you would get, this one has 8 gigs of internal flash, this one also 8 or maybe 16. If you want to use that internal flash instead of an MMC card, an SD card, then you need to have support for the NAND controller. And then you can just use it for a file system. It's just a block device, basically. But normally the NAND chips are not really nice to work with. People are used that a USB stick or an SSD just works, but there's a lot of stuff which you need to do on top with wear leveling and things like that. And normally that's all hidden away, and with these kind of cheap devices you have raw access to the NAND. So you need to take care of that yourself. And that needs to be supported in the kernel before we can actually use the NAND chips. Yes. How to start with these devices? It's actually pretty easy. Allwinner has an SDK, and they don't want that every vendor needs to compile their own kernel. So they ship with pre-compiled kernel, pre-compiled Android images, and they have a little INI file format called FEX, FEX files. And there actually is a FEX file inside the device if you buy it. So you can take that file and then you can find the DRAM parameters and which GPIOs they're using for what, etc. And there's a whole wiki explaining you how to bring up a new device, and most devices are already supported. It is over here. linuxfunc.org is where the community, the Allwinner community, has their own website. And of course, I'm not sure if I'm going to get anything. I already loaded all these at home because I knew the internet wouldn't work that well here. But that's the URL. Maybe at one point we'll also get a web page. But it's really easy. Basically, just buy a device and you can start playing with it. And you need to build your own U-boot and a device tree file for the kernel, if you know what that is. But there's also a linuxfunc.org IRC channel where people can help you. So it's not that hard to get started, really. There's a supportive community to help you out. Are there any more questions? Well, then thanks for your time. Before you go, let me plug one thing. I'm not sure if there is anything planned from the conference themselves this afternoon, but I noticed that the schedule stops at 4, the official schedule. Nearby, as in 10 minutes walking from here, about 200 meters in, I have no clue, I think that direction. If I have my orientation correct, there is the local hackerspace, the hackerspace from the Hay called RevSpace. It's a really nice place, and there will be people there tonight to welcome you if you feel like visiting a local hackerspace. And yeah, we'll have food and drinks, although, well, we can arrange food, we can order pizza or something if people want to stay for dinner. And this is where it is. So we are here right now, and you walk along the water. This is the highway and the railroad track, and then it's over here. So it's really close by. And I'll be going there myself after my next talk, so you can also walk with me if you want to visit. It did? You were curious there's not that much to see there. But I just wanted to show that there is a wiki where it has lots of information for people who want to start running Allwinner devices. So if there are no more questions, then thanks for your time.